Alright, so we're going to continue on with these problems. If you already tried 3 on your own, great, but I would tell you make sure that you pay close attention to what happens with this x plus 9 squared term with that square on the outside. So again, we pay attention to what's in between, because what's between them will determine what type of problem this is. Since there is division here between them, that tells me that I'm going to have to do the leave, switch, flip before I do anything else. So I'm going to leave the first fraction exactly how it is, x squared plus 2x minus 63 over 8x plus 56. I'm going to switch division to multiplication, and I'm going to flip my fraction so that 24 goes on the top, and the quantity x plus 9 squared goes on the bottom. Now, because I see that there's addition and subtraction here, that tells me I'm going to need to try to factor these. So, as we start to factor, the first thing you should always look for is a GCF. In this case, there is no GCF because there's not a variable in common, and the first term is a 1. So since the first term is 1, we can do what multiplies to the last, which in this case is negative 63, and adds to the middle, which is 2. So we need to think of two numbers that multiply and give us negative 63, but add to give us 2. So I believe 9 goes into 63, and it does go in there 7 times. And so if we make the 7 negative, then we would get a 2 when we put them together. So this will become x plus 9, x minus 7, and that would probably be a good guess since we see a 9 down here. There's probably going to have to be one up top to match it. So this goes away. There are no more exponents here, so that's as factored as I can go. Then I look at the bottom, and I realize that when I brought it over, I didn't bring the 6 with the 5, so it's x plus 8x plus 56, so we should be looking for a GCF there. And 8 does go into both of them evenly, so we're going to divide each one of these by 8, making my 8 my GCF. So we'd have x, and 8 goes into 56 7 times. Then I should try and factor this again, but since there's no exponent, I know that's the end answer. When I look at this one here, I cannot factor it because there's only one term. So these are my items that are on top that I've highlighted. This bottom one, be very careful. Remember how we talked about this in the other video. If there's a squared on the outside, what that's really telling us is I write what's in parentheses twice, and then it's already factored for me. So this becomes the new bottom there. Now we can write this as one big overall fraction. So we have x plus 9, that should be a minus, x minus 7, and then this 24 is a single term, so we're going to put it out front. Then we look at the bottom. There's an 8, an x plus 7, an x plus 9, and another x plus 9. Now be very careful here. A lot of you will want to cancel out the x plus 7 and the x minus 7, but one of these is positive and one of these is negative, so they won't cancel out. Also be careful, only one x plus 9 on the top can cancel out one x plus 9 on the bottom, and then we need to reduce our outside terms. So 24 over 8, 8 actually does go into 24 3 times. So this becomes a 3 on the top. We still have x minus 7, and on the bottom we have an x plus 7 and an x plus 9, and we leave our answer in factored form, so we are done at that point. Alright, number 4. Same basic starting point, right? We are going to have to, because there's division between them, we are going to have to do the leave, switch, flip. So we are going to leave the first fraction the way that it is, 36 minus x squared over 2x squared plus x minus 1. Switch division to multiplication and flip our other fraction so that it becomes 2x squared minus x over x plus 6. Now we're going to go ahead and we're going to start factoring this. So my first issue, which I think a lot of you will forget about, is I cannot factor this top piece yet. because look at the order. We need to put them in the correct order before we can factor them. So always we put things in standard form, so the x squared should go first. Now because this x squared has a minus in front of it, that becomes a negative x squared. My 36 is positive, so we have a 36. Remember how we talked about your first term is never allowed to be negative, so you're going to have to pull out a GCF of -1 here in order to account for that. So we're going to divide each one of these by -1, giving us x squared minus 36. After we do our GCF, that's when we have to try to factor what's on the inside. So again, these are both perfect squares having their differences, so that becomes x plus 6, x minus 6, and our -1 is out front. So now this is our new numerator for the first fraction. Then we can go ahead, and I'm going to actually do a little squiggle here so we can keep our two problems separate. Then we're going to go ahead and look at the bottom, and this one we're going to have to factor again because there is a plus and a minus sign here. So we look for a GCF. There is not one. Since my first term is not 1, that tells me I'm going to have to do guess and check. Now this one's a pretty easy guess and check because the only numbers that multiply to 2 are 2 and 1, and the only numbers that multiply to 1 are 1 and 1. So right off the bat, I know I'm going to have 1s here. I know I'm going to have x's, and that one of them is going to have to be a 2, and one of them is going to have to be a 1. And then we can do our checking to see what happens with the signs. So this will be a 1x and a 2x. And if I want 1x and 2x to give me a positive 1, then this one would have to be negative. So I would need to do -1 times x and 2x times positive 1. And a -1 times a positive 1 is a -1, so that works. So I can get rid of my check step, and I know this is 2x minus 1, x plus 1. And this is now my new denominator of my first fraction. Do the same thing over here with my next numerator. Always look for a GCF first. There's not a number in both of them, but there is a variable in both terms. So that tells me my x is my GCF because I take the smallest exponent. So I'm going to divide these by x to the first. Would give me 2. We subtract our exponents. 2 minus 1 is 1, so that'd be 2x. X divided by x, a lot of you will say that's nothing, but anything divided by itself is 1, so this is 2x minus 1. Then I would need to try to factor this again, but there is no exponent in it, so that's as far as we can go, and that's the new numerator for the next one. Then I look at this next one. I look for a GCF. There is not one in the denominator, and there is no exponent, so this denominator stays the way it is, and we'll just put parentheses around it. Then we can go ahead and write this as one big overall fraction, right? So on the top I have -1. I also have an x, so I'm just going to put that out there first because these are my two single terms. So -1x, then I have an x plus 6, an x minus 6, 2x minus 1. On the bottom, there's no monomials, so I can go straight to writing my binomials, so 2x minus 1, x plus 1, and x plus 6. So now we can go ahead and cancel out what's the same. So we have an x plus 6 and an x plus 6, 2x minus 1 and 2x minus 1. We only have one outside term here, so only one monomial in the numerator, so there's nothing to reduce, so then I can just write down what's left. On the top we have a -x, because we normally don't write a coefficient of 1. We also have the x minus 6, and on the bottom we have x plus 1. And then that's your final answer. All right, 2 more to go. Maybe you've already tried number 5 on your own, but there is some key things happening here, and we kind of talked about similar issues yesterday with multiplication, but this is actually quite different because you should see that this is an overall division sign. So if I were you, I would rewrite this as my first step. So let's write that note. I'm going to do my little squiggle. If written as a fraction over a fraction, rewrite so it looks, oops, too many O's, looks like other division problems. In other words, we're going to actually use that division sign, which we haven't used since we were in elementary school. So my first fraction is w squared minus z squared over 9. And then I'm supposed to be dividing this by w squared plus 2wz plus z squared. Now, this is the first issue. The second issue is that this last one is not a fraction, and so a lot of you will end up just putting it over 1 and stopping there. So we need to, as our second step, always make sure that both parts are fractions. So, to make this a fraction, we put it over 1. Now we can actually deal with this like we did all the other problems. But the issue is that there is twofold here. First, that there was a division bar to begin with, which we had to change into a division sign. And second is that the other piece was not a fraction, so we needed to make it a fraction in order to deal with it. So now we can do, because there's division between it, we are going to do the leave, switch, flip. So we're going to leave the first fraction the way it is, w squared minus z squared over 9, switch division to multiplication, and flip the fraction. So now it's 1 over w squared plus 2wz plus z squared. And now we can go ahead and try to factor anything that we can. So, in this case, the numerator can be factored because there's a subtraction sign. We look for a GCF, there is not one. But w squared and z squared are perfect squares and they're having their differences, so we have w plus z and w minus z. Now there are no exponents here, so I know that this is my new numerator. 9 is going to have to stay the way it is because there's no addition or subtraction. We cannot factor it. The 1 has no addition or subtraction, so it stays the way it is. We cannot factor it. But the denominator we're going to need to factor. Right? In order to get w squared at the front, there will have to be a w in each of these. In order to get z squared at the end, there will have to be a z squared at the end of, or a z at the end of each of these. Now, in order to get that too, we should check and see what happens here. This would give me, well, we write in alphabetical order, so 1wz and 1wz. 1 and 1 can combine to 2 if both of these are positive. And positive z times positive z is positive z squared. So this is my new denominator for that problem. So now, on the top, we have a coefficient of 1, or a monomial of 1, a w plus z, and w minus z. On the bottom, we have a 9, and we have a w plus z, and another w plus z. So now the w plus z's cancel. We should try to reduce, always, 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 and most students forget, reduce your outside terms. But 1 over 9 cannot be reduced. So we still have 1 over 9. We have a w minus z on the top and a w plus z on the bottom. Now remember, when you go to take any multiple choice test, this coefficient of 1 would not be there. So then your final answer would just be what was boxed. All right, last problem before you try the rest on your own is number 6. Now I want you to be really, really careful with number 6. If you look at what's between them, it is all multiplication, no division. Because this is multiplication, we can just leave everything the way it is and start factoring. A lot of you might be freaked out by the fact that there's 3 different fractions, but really we treat this the same way we do any others, and we just have to factor each piece and then write it as a big overall fraction. So this one is just going to take a little bit more work because we're going to have to factor everything first. So let's start out by factoring y squared minus 81. There is no GCF, but they're both perfect squares having their differences, so this will become y plus 9, y minus 9. Then I would try and factor this again, but there are no exponents, so that stays the way it is. So this is my numerator for that one. This one, there's only one term, we can't factor it, so we leave it 75. But the next one, again, we need to try to factor. In this case, there is a GCF, and 25 goes into both of them evenly. So I'm going to divide both of these by 25. 25 divided by 25 is 1, leaving me with y. 50 divided by 25 is 2. So that goes away. There is no exponent, so now this is the numerator of my second fraction. The denominator of that fraction cannot be changed because there is no addition or subtraction sign. The same thing is true for the next numerator. Stays the way it is, cannot factor it because there's no addition or subtraction sign. But this denominator I can factor. So I look at it for a GCF. There is not one. But my first term is a 1, so that tells me I can use a t-chart to factor this to find out what multiplies to the last, negative 18, and adds to the middle, negative 7. So 9 times 2 is 18, and if the 9 is negative, that would give me a negative 7. So this becomes y minus 9, y plus 2. This goes away. I need to try to keep always trying to refactor over and over again, but there are no exponents here, so that's as far as I can go. So now we can rewrite this as one big overall fraction. We have a y plus 9. Notice I always leave room out front for monomials. Then a y minus 9. 25 is a monomial, so it's going to go out front. Y plus 2 is a binomial. It goes in the back. And y to the 5th is going to get put together with that 25y out front. Then we look at the bottom. There's a monomial of 75. Monomial of y squared. Then y minus 9. And y plus 2. So now we can go ahead and cancel out anything that's in common between them. So y minus 9's cancel, y plus 2's cancel, and always, always, always check to see if there are terms out front that can be reduced. In this case, 25 over 75 does reduce to 1/3. Since there's division between these, we subtract our exponents. 5 minus 2 is 3. There's more on the top, so y to the 3rd on the top. We also still have a y plus 9 on the top. So then to rewrite this more neatly, remember we wouldn't write our 1, so it'd be y to the 3rd, y plus 9 on the top, over 3. Alright, so you should have recognized division and multiplication are the same exact thing. Just be careful, because if it's division, you have to change it to multiplication, then do the same thing that we did yesterday. So now you have the problems on the next page to try on your own, and we're going to check these 5 problems together in class tomorrow. Be sure to try each one of them to make sure that you're ready to go tomorrow.